Hey, Joe.
Hey, how's it going?
Good, good. Yeah. So, hey, you weren't here last class, right?
No, unfortunately not.
Yeah, no, no worries. But we were, yeah, I remember. That's why I mentioned that. Because I think one of us we were looking for you at some point for some reason. I don't know. Yeah,
Sorry.
yeah. In fact, you get, yeah, watch the video. Why was it we were saying, hey, where's Joe or something? I don't know. Anyway, watch the video. Yeah, we implemented a stack, and then you can share, your own insights on that.
For sure.
Are you enrolled in 2B now for Florida?
No, not yet.
No, but what is your plan? Are you planning to continue in computer science, or is this a wayward stop for you
It was a temporary exercise in, it was an experiment.
to find
Um,
basically tasters, right?
yeah, basically, my main love at the moment is design.
Oh, I
Um,
see. Like Ben.
so this was a yeah. So this was an
Yeah,
experiment,
great,
a
great.
test.
No, in fact, I was. I think I mentioned it another class, or maybe even last class. I forget when the others were there. It's actually super important for people that are in design and art to learn programming, or at least or in fact, I find the best programmers are usually ones who have an artistic mindset. They're looking for structure
Hmm.
and pattern, and then you can tell from their creations and the fine cuts they make, right? So they make fine cuts somewhere, and for a layman it doesn't even register. They just see the finished product, but the whole product has run through the artist's mind and it's there already, and so they're polishing these edges off, and they know exactly what kind of tool to use at each of these points. uh,
Hmm.
and I think that if once, and this is what I mentioned before, is that, see, computer science is a tool, right? I mean, it is a tool that lets you express yourself. You learn English, but not for the purpose of learning English, right? You learn English in order to be able to write beautiful things, right? So like any other art, it's not the means, although the means themselves may be very, there may be a lot of creativity around the means themselves, because it takes a lot of ingenuity to master the means. Just like, you need to be a master carpenter to know how to use every single tool out there, right? In the in the best possible way. Because if you think about how we as artists evolve, taking carpentry as an example, or whatever it is, right? So we reach a level at which we say, it's not worth it to think up, put in the mental effort to think up a more precise tool for a particular job, right? So at every time you're designing anything at all, this is exactly the dilemma that you run into, according to my not my experience. I don't know. All right, so it's just my hypothesis, right? So and I think that every artist in their mind has this perfect product, right? This is perfect product, meaning that it's been polished to the singularity, ad nauseum, to ad infinitum. Obviously that's not possible, right? So if given a choice, that's where an artist wants to take, right? So this car that Ben is designing, or whatever it is, right? So there is this ideal car in his mind, right? Or it's his product, and that's where they want to take it. But given that we are humans, what we do is basically say that is the ideal, right? And I know it's not going to be achievable, right? Humanly, right? So if you've given infinite years on a Turing machine, right? So maybe possible, but humanly it's not going to be possible. So let's just settle for the best compromise of the amount of effort involved and the amount of gain you get back. So the amount of gain you get back is the closer you approach to that perfectness that you have in your mind. The closer you get to the perfectness, the more you gain, really, because it gives you more pleasure as an artist to get closer and closer to perfection. But also, there's also this effort involved in getting closer to that. So as humans, we say, all right, so this is the amount of effort we need to put in to get that much of pleasure, and then that line gets drawn for us, right? So, and we say, all right, so as we are chiseling away, at some point we reach, according to the ability of the artist, right? So we all make these decisions and say, well, at this point, it's not worth my while to look for a finer chisel, right? So there is a finer chisel out there that will get me the exact shape I want for this person's eyes, right? So is it more effort for me, or am I good enough, or at least I think that I'm good enough so that I can use these, the tool that I currently have, which is the best I have right now. Even though it's not, I can see that is the best I have. Can I just make do with it, right? And so I think the level of expertise that people have in using these other finer tools, or knowing their existence and knowing how much effort it takes for them to go and get it, right? That distinguishes. That has a great bearing on the amount of effort you put in to develop your own product, which means you can get closer and closer to perfection, right? Because you have more time and expertise at your disposal because you're using the right tool every single time, right? Given enough time, most people will get the most close to the look and feel of the thing they have in their mind, but it just takes them a very, very long time. And so what these skills teach you right, is different ways in which you can leverage the power of all these micro tools out there, because you don't even know that you didn't know that they exist. So, but now you not only know they exist, but you've been given a 1 quarter or a 2 quarter playground, a supervised playground in which there's entire garage full of fancy tools, right, open to you, right, and said, okay, well, you're going to take a break from your artist mind for 3 months, right? And during these 3 months, just forget, you forget your artistic goals, but you keep your artistic mindset. And then now look at all these new tools that I've given you, right? So look at these millions of things that you can do, which you couldn't do before, right? So now, and then you have 3 months to practice. So it's really like a boot camp, right? It's a boot camp for most of you. It's a $200 boot camp, right, for 3 months. Where you come and play. You play with all the tools out there. And now when you exit the boot camp and you go back to your world of design, now when you want to do something, you will, as humans, this is what we do, right? When we have a goal and we fixate on it, we try and bring everything we have to bear on getting us closer to our goal, right? Whether it means calling friends and relatives or asking for help and not feeling bad about it, or all these things, right? So we do what it takes to get to where we want to go, right? Usually, right? If we didn't, we didn't want it hard enough, right? That's the only conclusion you can make. And and so I think, once you have these tools at your disposal, you can forget about it. So that's what I say, right? When people from other fields who do CS2A, this is a fantastic course. This is a fantastic course because you can do it. But if you do it, sincerely, meaning that you don't do it for something on a piece of paper, right? Sincerely, meaning that you're genuinely curious and interested. You want to know because it helps you make more sense of what people are doing out there, right? Because it's all mystifying out there, and I think Nate brought up this point last time too, right? And when you ask people, sometimes they give you a complicated explanation, and yes, and usually it is not because they have an ulterior motive in mind. Everybody tries to explain something to other people as best as they know it, mostly, right? Because when you're trying to share, you want to be as simple as you have understood it. So if someone has understood it but not as simple as you would like to understand it, well, then that person ceases to be a resource for you to understand that concept. That's the I think that's the best conclusion we can come to it. Anyway, so that's why
Einstein said that if you can't explain it simply, then you don't understand it well enough. And I think that's it's
okay,
very true for
yeah.
this.
Or you don't understand it enough to make it simple.
Exactly. Yeah.
Yeah. Okay. That's great. That's great. Yeah. I like it. Actually, speaking of simplicity, Nate. What's this other quote? We've used that quote 2 times or 3 times already in CS2A or maybe CS2B. Maybe you'll even find it on our Reddit. There is a quote about Einstein, attributed to Einstein, and it's about simplicity. Anyway, it'll come to me later. It's a really nice quote, and it applies equally well to CS2A and CS2B and C, right? All of our courses, really at Foothill, all of the programming courses I know of. Anyway, all of the programming courses I know of, it will absolutely apply. And maybe I should just, make it part of the Zoom or something, so that we just keep it as an overarching principle, right? So, and not that Einstein said it, but I think it's something that every human knows, right? And that is the heart of the Occam's razor, really. So Einstein said it in such a beautiful way, or said to have said it in such a nice way, right? So
It really is a great quote.
yeah, it is a really cool. I hope we remember that. Not this one. Not this is also the one you said. Also, I think is a great quote. But the other one is very nice. But anyway, we'll come to that. We'll come to that later. But anyway, I'm telling you, people like Joe and Ben and these designers. It doesn't matter. People should come and do CS2A or 1A and then go away, right? But do it sincerely and then go away. Forget about it. Because as a human, you'll naturally bring it to bear, right? Someday you're going to want to do something, right? You're going to want to do something, and all the tools that outside of computer science at your disposal can, cut the mustard, but not so much, right? So it'll be harder. So because as we get lazier and lazier, let's put it that way, right? As you get lazier and lazier, you want to do less work with your hands and body, and basically want to get the machine to do as much as possible for you. And so if as much of your routine art, because being an artist involves creativity as well as routine work, right? You got to be very good at the routine work and also bringing your creative insight to bear. So what you want to do as an artist, I think, is that just focus as much as possible, X and Y for the creativity and the routine work. You want to keep X as much as high, the X over Y, the ratio, you want to keep it as high as possible or something like that. And I think that if you know computer science, you can bring that to bear, right? So maybe you come back, in 5 or 10 years, and tell our students, if I'm still around, right? Tell our students, right? Especially here I'm actually a great artist, and you have an exhibit out there, and you say, and knowing computer science, learning computer science at Foothill, basically made me create these pieces, which I would not have been able to, right? Which I would not have been able to if I didn't know computer science. Maybe I'd have done something else, right? It's just that you have a new medium, right? It's a new medium that is allowing you to express yourself in combination with other mediums too. Who knows, right? So those are things, and that's why I said, when Joe, who was the first guy and the only guy to be in class, that's how this whole conversation started. Said that he came here from design and just as a taster to CS2A, and I was saying that that's really great to know. Like Ben, it's good to have designers and artists in CS2A. No, I'm not talking about 2B and 2C, but certainly 2A, 1A, 3A, those courses, where the especially someone who's majoring in art is not going to be doing 2A for credit, right? They want to do 2A to find out. Right. So if you're doing it for credit, there's a smaller chance, I think, that you actually pick up all the nuances, right? Which really make up the beauty, right? Everything, right? So it's always the nuances that make up the incredible beauty of things. And so if you're an artist, you come here and look for the nuances, really, right? So, and because you're not interested in the paper credit, you passed 2A or got an A plus.
Even as someone who came from well, I didn't exactly come from computer science, because before CS2A I was self-taught, but I did as someone who programmed before CS2A, even I learned a lot, like especially in Quest 9, which really surprised me, because that was like the first quest where I was genuinely lost for when I hit mini quest 2, I was just lost. And I didn't understand it at all, and it
But
took,
I mean, to be fair, we only covered linked data structures last week in class, right?
yes, yeah. So I was just I was trying to figure out like how pointers work and structs, and it was so
It's really hard. I know
overwhelming. But
it's really hard.
I was really proud after I got past quest 2 or mini quest 2. It started becoming easier and easier, and I got a much clearer picture of what all of this means, and it was genuinely enlightening, and and I thoroughly enjoyed it.
Oh,
So
fantastic. We all had a great deal of fun, I think, this quarter, right? And I was kind of, when the quarter started, this being the last class and all, right? I mean, we'll do the link class anytime. I mean, you take the stat class. I don't know who got the code. Maybe Michael has the code, right? We'll pick it up and we'll just need to make a few tweaks here and there and turn it into a link list, right? We don't have to do it, right? Honestly, at this point, you're going to be doing Quest 9, most of you, and that's all linked. And we shouldn't be doing link lists in class because that's exactly what you're going to be doing in your Quest. But if we do get to it in the end, that's fine. But this is the last lecture, unless you guys specifically request a lecture sometime next week. But this would be the last class, and both my 2B and 2C are completely online, right? Except for requested lectures, right? So meaning that we don't have scheduled lectures in 2B and 2C, but I usually tell them that if they want lectures at any time on any topic, they just need to pick a time, right? And let me, just like now, but except you guys have scheduled lectures, right? So 2B and 2C, you won't have any scheduled lectures, I think, from me. Well, at least not for the foreseeable future. I just realized that, I'm not teaching 2B next quarter. So I should talk to Beta and see if I can schedule things so that I can have all 3 sections going every quarter, so that I can have 3 cohorts, right? And anytime someone can do a 1A, hey, Peter, eat the apple first, okay? All right, go eat the apple first. So yeah. I was just saying, yeah, 2A. So I have these 3 cohorts, and then someone could do, a 2A starting in fall, and they do, fall, winter. Yeah, I don't know about summer. I figured something out, right? Because I think there's a gap, and people are emailing me saying, hey, whereas what about 2B? As my 2A students right now, you guys, so those of you who want to do 2B. But you don't have, I'm not giving you a 2B section this quarter. So yeah, I'll just give them a cookie this time. All right, here you go. We can have this cookie here. Yeah. Yeah. So I think so. Next quarter. So then I can make sure that we don't lose continuity. Right now, I think some of you are in a quandary because, do you wait for the continuity? But I actually suggested the best of both worlds, right? So you can do someone else's 2B. There's so many sections. There's so many people at Foothill offering 2B, and then you can do the quests on the side for free, right? And you participate like you are a regular student in the sub. And I think you'll be fine. Yeah, and by the way, how many students do we have? We have not the whole class, but many of you are here. You guys should in fact nominate people for the most helpful member, because and pass this word along to all of the classmates, right? Maybe do a post or Reddit or discuss it in Discord, in your Slack channels, wherever it is. People need to know that at some point some of you may come and ask me to write university recommendations. Maybe, I don't know, right? So
I have a question.
Yeah.
How do I nominate someone on Reddit? Because I was looking for that.
How do you what? Oh, nominate someone on Reddit? Yeah. You just have to send me a private message or email. That's all. Right, but you need to. There are some rules, right? You got to check with them first, and so on. So just see the post on Reddit, right? It's called on the syllabus, right? So check the post. You just need to get the permission, and the conditions are that they shouldn't have already won it once, right? So so once you've got the $250, that's it, right? You can't be an MHM anymore in that color. Well, obviously, let's say that Chad at some point, maybe not this quarter, right? Maybe this quarter, maybe some past student, not even in your section. It may be in your section. I don't know, right? But maybe there's a past student of 2A that you all found were like super duper helpful, and you get in touch with him either via Reddit message or email or whatever it is, and manage to contact him and say, I'd like to nominate you, and you nominate that person and do all those things, right? Give me that one link that you are that gives you the reason to nominate them, right? So that person wins it. Right, because let's say because of the voting and everything, and wins it, and yeah, some of you are going to ask for university recommendations. And as I said in the syllabus, right, I just stopped writing comparative recommendations and also specifying your grade. Right, because what it doesn't really mean anything. If someone came to me and said I got an A+ in CS2A at college XYZ, even if it's Harvard or Stanford or whatever it is, right? I can't tell. I don't know. Maybe they got through because of. You need to converse with them for a little bit and try and probe if they're thinking the right things in the right way, right? And so I don't do, right? So when colleges ask me, rank the student between 1 and 10, no, I don't do that. So you can feel safe that I won't be judging you or evaluating you in any way. If anything, I'll let the system speak for itself, meaning that, it will basically be objective in terms of how much score. But I do have one subjective element here. And I think also I'll try and make that as objective as possible, which is really how much participation points I give you guys. Yeah, but, usually I tend to err on the more a generous side, honestly, because it doesn't really matter so much to me, but I don't at the same time want people that basically didn't even show up, and then it makes the whole point system meaningless. So you can assume that most of you guys who've been speaking up or volunteered in class, even if you've been absent a couple of times, that's fine. Right, and even having independent conversations. After last class, I think I left the recording on. You go and check the YouTube video at the end segment of our last class. I think last 15 minutes or so, you basically have a tech talk show. You think about it, rather than play it you as like what is it? What are the things called? The little podcast, right? You can play it and listen to it. It's like a talk show. And it's really cool, and because in the talk show in the past, they used to do on radio. I think they used to do a lot of playing around with the audio to make it sound right and all, and that's all being done automatically now. So I was just listening to it, and I wasn't even in front of the computer, right? I was in the next room, and it sounded just like a talk show. So it's really cool. So you guys can get together and maybe host. Yeah, at one point, I think. There was a student, there were a couple of my past students, right? Ibrahim and Sean McPherson. I think, right? They used to host a talk show at Foothill on campus, right? Where they would invite fellow students and, staff members, sometimes even celebrities, I guess, right? And they'd have a talk show, and it's really cool. And they ran it, well, they're not here. I mean, they've all gone off to UCs now, I think. Oh no, maybe they've even graduated from UCs, right? So maybe they're working somewhere. But they used to run talk shows. So you guys can consider this, right? So you can say you can have a CS Club talk show, which is basically a tech talk show, and you can take what you had from last class and get together in bunches, groups, right? And basically take an interesting concept. There's a bunch of those on the net. I think if you go to YouTube, you'll find a couple of just a couple of guys or girls, and a bunch of people having interesting conversations, and that's very interesting, right? So you can think of all that, right? It opens so many doors. That's a cool thing. Okay, all right. So I'll give you an acorn now. Hey guys, so what we can do is basically we can pick up the code. We can pick up the code, and here. Yeah, if I give him an acorn, he'll be gone for like 5 or 10 minutes at least. I think because when I used to give him these nuts, I had to give them one by one. Because if I give him a whole bunch at a time, then he's a very resourceful little squirrel. Hey, can you guys see the squirrel? I got the iPad camera. You got to look at the iPad camera, I guess. We can't see him now.
Yeah, I've been watching him when he's coming by.
Yeah, it's kind of cool. So if I give him a lot of nuts, he will not eat them immediately. He'll take one by one. One by one, he'll take them away and start digging holes in my garden. Right, and so and burying each one of them, and he actually remembers where he puts them, and then when there's 1 or 2 left, he'll basically just eat them. And so I figured, well, I don't want him digging holes here, so I'll give him these nuts one at a time. and it got to be painful. And then I just spent some time covering up all of the places where he could potentially dig up. Now I can give him nuts, and he can't bury them all here, so he has to take them away, and he's got to be out for like 5 or 10 minutes sometimes. So especially this acorn, right? So he can only take one at a time. So it's kind of cool. Yeah, but I got to be even more scientific about testing the difference between the walnut and the acorn. This is, ultimately, this is all what computer science boils down to, right? So I think computer scientists really are scientists, right? They're programmers. The best programmers are also the best scientists, because I say that because all of science really is really about constructing very careful controls. Yeah, that's really what it is when you're trying to isolate a particular what is it, manipulated, or whatever it is, right? So the dependent, independent parameter, right? So when you're trying to isolate a particular parameter, you got to hold everything else in check, right? You can't have everything moving around. So, right? So science really is an art in which you figure out everything else that you want to control, right? Basically keep constant, so that there's one thing you can vary and see how the response varies. Hey, Peter, that's it. Okay, I'm not giving you any more until the class ends, right? So so you want to vary only that thing, and so as you do science, again, science, like computer science, is an art where in science you basically learn to think so fine, so that you're able to say, well, this is the very, very precise condition I'm trying to measure in this. So I have to set up an experiment. So, I think we talked about this before, because in modern manufacturing processes, a great deal of effort, even more effort, goes into designing the machine that's going to design your product, right? So making the die in which that thing is going to be cast, that itself takes a great deal of ingenuity, right? So, and like that, science prepares your mind by saying, well, you can look at the problem in this particular way and then design these experiments. The science is all about designing experiments, right? As humans, is what we've been doing all along, ever since we were born, right? We're doing experiments after, it's experiments, just sitting down, watching other people, right? So they're all experiments that we do to figure out, not figure out in the bad way, right? There are always people around you trying to figure you out, right? And they're wasting a lot of their cycles. So you can gain a lot of those cycles by stopping, don't figure people out, right? So you can figure things out, don't figure people out, because you can never figure people out. And it's all a waste of cycles. And then when you try and figure people out, you just create politics, and it's all nasty and takes up a lot of your brain cycles. And the politics will basically just loop around and come back to the same place, right? And then you haven't gained anything at the end. So the best thing to do is basically don't try and figure people out. This is lots of people out there trying to figure you out, right? Judge you and figure you out and set values and say, right? This is a waste of time. And you find out eventually, oh my gosh, thank goodness I don't do that anymore, right? And when you do that, you find you have a great deal of time at your disposal, right? Because you have immense amount of time to do whatever the hell you want. So anyway, how do we, in science, right? In science, so we say, so here's how we construct our experiment. So here are the great tools you can use that science gives you, which lets you make a particular kind of experiment, right? It's a very incredible experiment that you can't even dream of, right? But science gives you the ability, using all these other tools. Like Einstein, right? So he made this observation that light has to bend, right? Gravity bends light, right? Or basically gravity is, there's a space time, and then the light follows, right? So he made that observation, and how could you test it? You can't test it here. So you had to wait until, and so the way to design an experiment to test Einstein's theory, right, is itself a Herculean task. Yes, it's because he's making a prediction that can only be tested by something that is interstellar, right? And here we are on planet Earth, right? So just making sense of it is hard, but after having made sense of it, testing it is a Herculean feat, right? Most humans will say, no, I can't even do it. Right? So it takes a great deal of ingenuity and knowing about science, right? If you didn't know science, you'll say, no, well, it's a wild ass prediction and it's not even going to bother, affect my life. I don't care, right? So you just let it go. But if you know science, you bring things to bear from other fields that you've learned in science, right? Mathematics, tensor analysis, all these other things you bring to bear and say, well, you know what? With all these tools that I have learned in science, right? So these are tools that you wouldn't have learned these tools if not for science, right? Science gives you these tools. Now you can say, well, you know what? With these tools, tools that I've learned, vector calculus, right? Tensor analysis, and this speed of light measurements, all these things. With all these tools, I can devise an experiment, right? We're not even talking about, I can devise an experiment which can either prove or disprove Einstein's wild ass guess, right? Wild ass guess that light will bend under gravity. How cool is that, right? So even devising a test to disprove an experiment, that's hard. And it's only possible because you had at your disposal all these many tools, which you wouldn't have had if you didn't have training. Right? So science prepares you for that, saying, well, here's a way in which you can develop these extremely fine controls, right? Because if you're not a good scientist, you'll still perform the experiment, but your controls won't be as fine, right? You won't be able to chisel away these fine pieces of sand, right? So you will still have a shape, but it'll be more Gaussian, right? So you'll have edges, right? Instead of a peak, you may have a bell or something like that, right? So that's the experiment performed by the vast majority of people, right? Because as you get to be a scientist, you can get to be, reduce the standard deviation, right? And you get more and more to be a pulse, right? Because you know how to control. Right, so you make finer cuts, and I think computer science is not very different, right? So you can take some guy off the street, right? And teach him or her some basic programming, right? So basically, a 1 week boot camp, one week boot camp. Yeah, at the end of the week, it's entirely possible. They could come out and say, I know programming, because the truth is, they can do with programming any task that is given to them that needs to be done with, not any task, right? Most tasks that most programmers do, they would be able to do it. But the difference is that that's all they know. That 1 week they've learned, they only have a small set of tools, and they will try and jam everything. Anything they want to do, they'll do it with these tools, right? And you can, right? So as you know, you don't need a sophisticated language like English, or you don't need computer science. I don't mean science. You don't need C++, Java. You don't need, because theoretically, we can just code in ones and zeros, like von Neumann, right? Because if you think back to it, BIOS, right? How does the computer, how was the very first compiler built, right? So it's a C++, the C++ compiler, you'll be surprised to know, it has so many different things in it, right? But it translates things from C++ into machine code, right? Ones and zeros for that particular architecture. So, but how was that the translator itself written? Right? So this is a translator that takes C++ and turns it into machine code, but how was that translator itself written? So we think, oh my gosh, that is called the bootstrapping process, right? It's a bootstrapping process. And that's another ingenious thing, right? We've discovered, just like, genes and everything, right? So we start off really, really very simple organisms, which don't do anything at all. This is basically react to light and not light, right? And then slowly over a period of time, millions and millions of years, right? So it kind of evolves because some of them die away, many of them die away, the surviving branch, it gets more and more sophisticated, right? So this is a theory of evolution. And so where are we going with that? Yeah, I don't know where we're going then. Sorry. G. Yeah, I just start talking about this. Branch. I don't know, guys. All right. Anyway, maybe it'll come to us later. Well, yeah. What time is it? Oh my gosh, 8:35. We should really start talking about implementing the linked list. Hey, there's stuff in chat. Hey, cool. Yeah, cool. Great. Anyway, so smaller gap in between would be nice. I don't know what that is. 2A, 2B. Anyway, so you guys, does someone want to pick up the code and do a linked list or talk? Talk is fine. Yeah, this is really the last class, right? So we've covered all the important stuff, right? We've covered Really just C style strings. You can read up on that stuff, right? You can read up on that stuff. It's all on the net. C style strings, you can extract the C style string outside of the string object. This string is an object, right? In C++, it's an object. It's got the C style string inside of it, right? It's not because the string does a lot of sophisticated things. There's multiple copies of the same string. It doesn't create multiple copies. It just takes one copy and keeps a reference count, right? Unless the string changes, there's only one copy, right? So all these clever things are built into a string class. But the raw string, the C++, the C string, the array, correct array, that's all. Hey Peter, I told you not now. Okay, I'll give it to you after class. All right, come back at 5. Yeah, come back in 2 hours. No, after 2 hours. Okay, not now. All right. Yeah, it's C++. Yeah, I think we're talking about C++ machine code. Yeah, how the compiler process. Yeah, I think that nobody reminds me. Maybe you guys don't want to talk about that. So it's fine. All right, so but basically that's what happens. The compiler, the bootstrapping process is basically the C++ compiler compiles itself. Right? It's the C++ program, and here's the machine code. Here is the compiler, which turns the C++ program into the machine code. All right. How do you get that? Right. How wrote this program? Did this program get written all in ones and zeros? Right. Did von Neumann come and write this programs for us? Because von Neumann is the only guy we know, at least apocryphally, right, according to stories, that he can actually program in ones and zeros. Right. So for a given architecture, he's just given the an Intel architecture, the instruction set, he'll just memorize it, and later on he'll just say 1 0 1 0. So I think it's like that, right? This is Amadeus. This is a movie, Amadeus, right? Maybe it's on Netflix.
Wait, so the C++ compiler is written in binary or
so what happens is that very few people write in binary. So what people do is write in so you remember that every binary is basically also hexadecimal, right? Because in a binary is 8 bits.
That's what machine code is then, right?
Yeah, machine code is hexadecimal.
Okay.
Right?
Okay.
So
yeah.
The machine code it's 8, so it's hexadecimal. So technically, all of the instructions are basically hexadecimal numbers. They're 2-digit hexadecimal numbers.
I see.
1 byte instructions. Right? But even then, programming in binary is really, really super duper hard. Programming in hexadecimal is really, really super hard, right? Super duper hard, super hard. Okay, you still program in hexadecimal, not so hard. I believe me, I've done that only once, right? But so what people did was, it's always the same hexadecimal going to the same binary, right? So why don't we take that hexadecimal and give it a human-like name, right? So instead of F3, why don't we call it ADD? Right, because F3 basically means the add instruction, right? So instead of F3, we'll say add. Right, so that way it looks more human. And so in my program, instead of saying F3, I could say add. Does it make sense? And then some program.
Oh, I see. Yeah.
Right, and some program can look at my program, which I've written very human-like, say add, move, shift. Oh, I've written right, because each one of those shift is basically E2, right? Add is something. So there's a mapping, right? But you can easily do that mapping with the dictionary. Right, a hash table or something like that. So what you need to do is now basically just write in terms of roughly human readable. That's called assembler code. Right? So the assembler code is roughly human readable, but still can be mapped 1-to-1 into binary. Right? So the translation from assembler to binary is really simple. Right? Because the translation is basically a 1-to-1 map. You can write it in Python. In fact, it is so simple that you can basically write it in assembler. Right? But going from assembler to binary is basically a lookup, right? So you can actually do that. Once you do it in assembler, you can basically translate it manually into hexadecimal, right? So if you translate manually into hexadecimal, you can basically load your chips. So that is called the basic assembler, which is part of your BIOS, which basically knows how to build the very first assembler, which does something more sophisticated than this very primitive assembler that only knows to translate from assembly to binary. Now using assembly, write a very, very simple C++ compiler or even C compiler, very simple, right? Doesn't do much. And using assembly, that's possible because assembly is always kind of human, right? So and very simple. Now use that C compiler to write a more sophisticated version of a C compiler. That's possible.
It
right?
writes itself?
Yeah.
Oh,
so
cool.
It's like deep thought, right? It's a deep thought in Hitchhiker's Guide of the Galaxy, right? So they eventually build a computer do you guys know the story of Deep Thought? I can tell you the story of Deep Thought in the Hitchhiker's Guide to the Galaxy.
I haven't heard of it.
You haven't heard of it? Oh my gosh. Yeah. It's a very nice little story. Let me see if I remember it correctly. Right. If one more person says, yes, I'd like to listen to the story, I'll tell you what the story is. Right. So it's from the Hitchhiker's Guide to the Galaxy. You can look it up on the net too, if you like. If you want me to say, if you say yes in the chat window, I will tell you that story.
I remember it pretty well as well.
Yeah, I
like
read
the
the books a
Hitchhiker's
while
Guide,
ago, but
really.
I read the books a while ago, but I'd love to hear it again. I kind of don't really remember that well.
Yeah. Okay. Yeah. Let me see if I can remember it. Okay.
I have a few ideas of how it goes.
Yeah. I remember it now. I do remember it. Yeah. It's a civilization out there who want to know. So this is very, ancient civilization and very advanced. They've been there for a long time, and they've done massive advances in computing, science, and technology, right? So they want to know at this point. Everything has been taken care of. They just want to know the answer to the life, universe, and everything. So they want to know the answer. And they try hard and they can't find out, right? So eventually one of them says, I'm like this master programmer, right? So who's like, not a master programmer, he knows everything, right? So he says, I can build a computer that can compete, right? Because right now that's what we're building an AI system, right? So I can build a computer that can find the answer to this question of the life, of life, the universe, and everything. So we as these creatures, or let's say humans, right? So we can't, these aliens, we can't find the answer. But I have this, we can build this computer. And so people say, yes, okay, let's go and build this computer. How long will it take? And it says, the computer, to build this computer, it's going to take 7 billion years, right? So they work on constructing computer charts and keeps going on.
If it helps, it's not that the computer takes 7 billion years. They build the computer relatively quickly.
Oh, they do?
The answer.
It's computing for 7 billion years.
Yeah.
Thank you.
The computer sits there and sits there and sits there without doing anything. And they're like, the hell?
Yeah, go ahead. That's really nice. So they're all sitting there. They commission the computer, start it, and it says, I'm going to give you the answer in 7 billion years. Right, so they just start worshiping it, right? So for 7 billion years, many people say in such and such a time, we're going to get the answer from this thing, right? So they keep worshiping it, and at the end of 7 billion years, some future generations, their descendants go to the computer. It's called Deep Thought, right? So the computer is called Deep Thought. It says, okay, Deep Thought, you've had your time to crunch through this algorithm, right, and find the answer. What is the answer to? And then they open this unfurl this parchment that's been buried in a time capsule, 7 billion years, right? What is the question they wanted to ask this computer? Oh yeah. Okay, it's what is the
meaning of life?
The meaning of what is the answer? What is the answer? What is the answer to life, the universe, and everything? Right? Oh, that clever ancestors. They got a really cool question there. Okay, and then Deep Thought says, yes, I remember the question now. Was asked me that 7 billion years ago, and I was crunching the answer, and the answer is 42, right? And so these guys are completely baffled, right? So how could 42 be the answer to life, the universe, and everything? So so Deep Thought says, the answer is confusing to you because you didn't ask the right question. This is what happens in our subreddit all the time, right? So people have a bug and they don't ask a question about the bug, they ask something else and they get a different answer, and sometimes they're confusing, right? So it says, oh my gosh, then people realize after 7 billion years, oh yeah, okay, you know what? We got to ask the right question. What is the right question to ask? And Deep Thought says, at that point, you know what? I'm like a super duper computer. I know everything, but even I can't tell you what the right question to ask is. However, you guys built me to give you the answer, but I can build an even bigger computer. You guys can't build that computer, but I can build that computer, right? So I'll build that computer for you, which will go away and figure out the right question to ask. Yes, right. So and these guys are now overjoyed, right? So they've already waited some. So they said, yeah, okay. How long will it take you to build that computer, which will give us the right question to ask? And then Deep Thought says, yes, it'll take you. This computer is. Yeah, okay. So it says this computer is going to be called. You're going to be components of the computer. Yeah, okay. So you will take new shape, right? So it'll look at the people that are asking it the question and say, now you guys are now going to be the components of this computer I'm going to build. right? So there is this master computer in which instead of chips, we have these little cognitive units, and you guys are those cognitive units. And so eventually, this computer that comprises you, called Earth, right, will come up with the right question to ask. Okay, so but I know how to build that computer, so I'm going to build it. So right, so it's really cool, isn't it? So it's and very nice little story. I don't know, Michael, or Peter, you can correct me if I'm wrong.
So that's where 42 came from. The whole
Yes.
the answer to life, universe, everything. is-
Yeah.
Yeah,
In fact,
that's
The answer is 42.
there was an interesting tweet about 42 when what is that particle that was the God particle? What's it called? Boson. Boson. Yeah, boson. So when accelerator CERN, they published literature about the boson thing. A very catchy tweet became viral at that point. I think it was 2012, or maybe 2011, right? A very catchy tweet came out, and it related the number 42 to boson somehow, and said, the boson is the fundamental unit of matter, but it's also because 42, and 42 is the answer to life, universe, and everything according to the Hitchhiker's Guide, and therefore Douglas Adams is like the mastermind who could see all that kind of crazy shit, right? So it was fun at that time. 42.
Fun
In fact,
fact,
there was
the computer that the computer that DeepMind made, what it was is that the DeepMind said,
it was Deep Mind, was it not Deep Thought?
or sorry, Deep Thought. You're right. It was Deep
No,
Thought.
but Deep Mind sounds is what is Deep Mind? Is that
DeepMind is the Google AI. I was getting him confused. You're right. It's Deep Thought in the book.
Okay, but what is IBM? Because IBM also had this thing, which is why it was in the Jeopardy show. It was called Deep something.
IBM's is Watson, I think.
Yeah,
Isn't it
maybe
just
IBM.
like Watson.
Oh yeah, it was Watson. His
Watkins.
name was Watson.
Yeah. It was Watkins.
But yeah. Anyways, what it was is that he was going to the planet was going to make a machine that would be so large it would resemble a planet, and
Where
be
is this? Where is
super
this?
this is the Deep Thought.
Oh.
In order to create the question for the answer 42, it needed to create a machine that would be so large it would resemble a planet. It would be so complex that life would become part of its operating matrix, and the creatures that made it would evolve into mice and watch over the planet and watch over its 10 million year long program. And the new machine was called Earth. And about 5 minutes, 10 million years later, 5 minutes before it could reach the question, at the very beginning of the book of the Hitchhiker's Guide to the Galaxy, as it opens up, Earth is destroyed.
Oh, I see. Yeah, wow.
So 5 minutes before it could find its answer, somebody made way for a interspatial highway.
I see. Oh, that's interesting. Yeah. I remember that now. Honestly, the funny thing is, I most of the time, maybe it's everybody, not just me, right? We don't read the whole book, right? We just read certain parts of it. Even though we read it, it just registers for like a half hour, right? And then we just remember chunks from it. So I don't even remember some of. You said something about mice. Did you say something about mice, Peter?
Yeah, the people who made so the Hitchhiker's Guide loves to throw in these ideas that a lot of the species that are on our planet are way smarter than us and like way unfathomably more sentient than we could understand. So dolphins are one of them. Mice, I think squirrels as well.
Oh, I see.
There's a few other ones that they say that are there, but the mice especially were the race that invented the original Deep Thought.
Right.
And they just evolved into mice in order to watch over the
I missed that. I totally missed that.
Or
In the book.
yeah.
Thank you but it's very nice. It's very nice. See how you can read. There's all these things that you miss, right? Even if you try to get everything out of something. So
I don't think I've ever gone and reread a book and found nothing that was new to me. Like I think every time I've gone and read a book, I'm like, oh,
this is
that
like a
happened.
dictionary.
Oh.
Dictionary, right? You see, never ever. Right now, I haven't run into the problem because you just go to Google or Siri and get to the meaning. But before that, I used to have a hell of a time finding the word I want in a dictionary because I always go, I open it up and I get lost in some other word, and so yeah, it's like that.
Mm-hmm.
In books, like you said. That's why I don't even feel so bad anymore that I don't get everything out of everything, right? So if I buy a movie or if I watch a book or buy a product, if I don't enjoy 100% of it, that's fine. Even if I don't pay for, this is because I can't get it anyway. That way I leave a little bit of it the next time, otherwise it won't be once. So that I think it also frees me up because I don't have to worry about anything, right? So I don't have to worry. Just say, yeah, okay, well, if it's a extra few bucks, it's not going waste. Right? So that guy is going to enjoy it, right? So, and then so you're not looking for the best deal all the time, and you don't have to worry all the time about these details that really detract from getting more out of things. It's really like C++. I think in CS2A, we worry a lot. We worry a lot about the micro detail. We say we're not going to try these more ambitious or aggressive algorithms on vectors because we're afraid. I don't know if you've actually felt it, but many people have told me that they almost have a visceral fear of playing with a vector because they're afraid that they'll run one off and then the computer crashes or things like that. This only happens the very first few times, right? Because if you have your edge conditions correct, in fact, you should in fact fall off the edge, right? You have to fall off the edge a couple of times to know where the edge is. Right? It's better to fall off the edge when the edge is close by and people are here to haul you up again, right? So like in our class, than to fall off on your own, in your own product, or when we have deliverables. It's a bit of a pain. So you have to fall off the edge, and you have to not fear. You have to overcome fear and say, I'm going to try it. I'm going to try it, and if it breaks, you have to have that don't care. And I think the people, and in order for that to happen, you also have to be less worried about your grade, right? So you have to be as less worried as me, right? Which I know it's not possible because you got a lot writing on it. But you shouldn't be. I think. Which fortunately is not happening in our class, I think, right? Because many of you are just focused on learning the interesting things. But in the past, I've had people, when I've taught the class in a different way, I've had people who didn't really care, about whether they got the answer or not, as long as they got the answer. And then I figured that, giving answers is not the same as giving help, right? And as teachers, we're supposed to give you help, not answers. And because, we're not going to be integrated into your DNA. Right? We're not going to be, integrated in DNA and be part of you all your life, right? So it's just like 3 months, and then we say we can just give you all the facts, and we can only say, this works and that doesn't work, and stick around for that to happen. Yeah, okay. So what you should do is, recommendations and MHM. You should nominate other people. Absolutely, send me email and so on. Because when it comes to college university recommendations, that's what I wanted to say at that time. I completely forgot. Right, when it comes to university recommendation, I don't say this nothing. So what I do is this person was a student, and as far as I'm concerned, they participated nicely in their discussions with others. You can see for yourself. Here's a user code on all the public forums that I know, right? So I'm not going to share your Discord or Slack channels and other things like that. You can have your, right? But I'll say, here's their Reddit contributions, right? Here's the Reddit contributions. And I'll make a special note if at some point, not this quarter, right? So maybe you don't nominate yourself and someone else nominates you. Right, so and next quarter in summer, someone nominates you, and you end up winning the most helpful member prize because of posts you made now, which become valuable later on, right? Or get votes later on. So you win it now. If you get that prize, I'll also make a note of that. Right? And say, well, all I know about this person is that this is their user code on Reddit. You can go and find out what they contributed yourself. And of a special note, you can see this thing where they also he or she was voted as the most helpful member in that section, and that really means a lot. You'll be surprised, right? So it's not just grades, because people know these days in universities everywhere, right? Grades can always be gamed, right? And the fact that you have good grades does not guarantee that you'll make a good graduate student. Yeah, I know that from experience, right?
Means you're a good student, not a good.
Yeah. A graduate student is an entirely new ball game, right? So that's the mistake that I think many students make, is when they go from high school through community college to grad school, right? So when they make that transition, they try and take the same approach to learning that they had in high school, which is kind of, I don't know, it's toxic to learning, right? Which in the Bay Area anyway, is that it's more focused on achievement rather than on improvement, right? Improvement is when you learn something that can improve your life, right? Achievement is when you get a piece of paper that can give you money that can improve your life, right? So so you see how that the second step is the thing is one step removed from happiness, right? So it's both of them eventually, maybe right? There's also probability distributions and everything, but this thing here where you get a piece of paper which is going to give you money or something that is going to result in happiness, so there's this one extra jump you have to make there, right? Whereas here you basically learn something because it was useful, and it's useful and it results in happiness, right? Because you can make something that's so there's no jump, right? It's direct, so it's one extra jump. And you'll know when you do graph algorithms how you even that one jump is going to reduce your probability of success exponentially, right? It's really funny how these things happen. And I think yeah, I don't know where we got helpful, right? So that's so as a professor, if you want to pick the best grad student, you really want to pick someone who's interested in the subject and is also so interested that he wants other people to be interested in it too, right? So if you want other people to be interested in it, then you're going to be really good at it because you'll be able to explain it to them, right, in simple terms, like Nate said, right? So you have to be very simple because they've managed to break it down into such simple terms that they can go as complex as they want from there. Right? Because if you have sand, you can build anything you want. But if you already have pre-constructed shapes, it's harder to build any other shape because you may have jagged edges you have to sand off and things like that, right? So the finer you go, the more generalized you can become later on. And
that really is so true, because a big part of me wishes that I didn't try learning programming on my own, and I kind of started, and I wish that I started at a more I would say I don't know, like a class or something
Academic.
like that, because I basically what I did was there were a lot of basic things for a very long time, and even now, honestly, well, actually, I guess CS2A kind of paved a lot of the holes through, but my knowledge in programming was like a very unpaved road. I knew a lot in like certain areas, but then in very basic areas, I didn't know that much, and there was a lot of things that I was doing which I didn't, which were bad, and I didn't realize that they were bad because nobody told me that they were bad.
Right.
Like I don't know. I think it's important that like you have to lay the groundwork before you start.
Yeah,
build-
I think so.
right?
I think so.
And
I
you're
totally
not
agree.
you don't want to build a house that, just put some sticks up and then try to see if it stands. You have to have a solid foundation, and without that foundation, you're severely limited in how far you can go, I think, or at least how far you can go before things start getting really noticeable that you don't really know what you're doing.
Yeah,
So.
and
think
I
it was-
agree.
I think it was you though, Nathan, where you were sharing your screen and you would use a lot of hotkeys to format your code, or you would like replace all like throughout your code, or you would like tab an entire thing at the same time, and that's not something that's taught in class. I've been through about a year's worth, I guess, of coding courses, and like I've never learned anything close to that, nor did I know to do any of that. So watching you code was very useful for me because I was like, oh, there's like a bunch of hotkeys I sort of had knowledge of, but really never knew how they worked. And
The
that was interesting. Like, it's
By the
not
way,
something that you'll see at the end result of code. It was just something that you'd only see by looking at the process of it.
I know what you're talking about, and the way that I kind of try to approach how I write code is the less I have to move my mouse, the better. If I can just use my keyboard,
Yeah.
then I'm good, and that's just what I try to keep in mind every time I code.
Smart.
Yeah, and by the way, thank you so much for all of you guys, right? So I think every one of you here, Ryan, Joe, Ben, Chad, Nate, Michael, Peter, Robert, Susanna is not here, but is Susanna here? Susanna's not here. Yeah, okay, Susanna, I think most of you, you've been up here on stage, and when you're coding, I have to thank you really, because you made so much it was life so much easier. Let's put it that way, right? Because you know how difficult it is, right? As coders, you probably know how difficult it is. And sometimes, I'm trying to say we're trying to do something, and you already start typing that, right? So, and you finish up things, and you make sure the syntax is right and fill in the details. I know it could be potentially challenging to some of the students who are still trying to catch up, that just some of these details that you fill in automatically, like semicolons or fixing up syntaxes when I'm saying the wrong thing. So they might, but it actually because they might think, oh, I need to have done that and been burned by that, but you actually I don't know, right? But I think it's helpful, like Nate said, to watch these things, like you guys coding, and then learn how to do these automatically, right? So so that you can focus more on the thinking, and then the formatting, you can basically say, like you guys are doing, you can just you can keep thinking the logic and typing typing the syntactically correct code, which is a really hard skill. It is a hard skill and to master, and it takes a lot of practice. So thanks. And the only thing I wanted to say was that the people who are not quite there yet, right? So don't feel overwhelmed, because it is a skill. It is a skill to be able to think about the logic and also express it syntactically in the right way at the same time, right? But like they say in writing, right? So when you're in English course, an English course, and when you have to do some writing, what they say is that don't worry about the grammar. So when you want to do something, don't worry about the grammar. Just dump all your thoughts into you just open a text pad or a notepad window, and then any damn thought you have, right? You have a thought about clouds, and just type the word cloud, right? And then come back to it later, right? And then say, cow jumping over the moon, right? So it's a random phrase, just type it in. All kinds of junk, right? So type in all kinds of junk and do that for a half hour, right? Half hour, that's the beginning of your essay. Right? Obviously you have an orbit, right? You'll have what you're going to write about, all your thoughts about it, whether right or wrong, just dump it, right? And don't care about the syntax, right? So, and then go through it, and through the list you've made, and see. Now you can start getting creative and say, well, I wrote down clouds, but how is clouds related to the history of the Ottoman Empire? Right? Maybe you have to write an essay about the Ottoman Empire, right? So, and you wrote down the word clouds, right? And then you can start to think and say, oh, all right, so there's one possible way. Let me turn that one word into a proper, grammatical sentence now. But at least you know now what you need to do, right? So you take the cloud and turn that into a sentence that relates it to the Ottoman Empire. And that's your version 2, right? So you went from completely ungrammatical to grammatical and somewhat related, more related than before, right? And a lot of stuff gets, fluff, weeded out. 90% of the material you wrote down in the first half hour, gone, right? But you actually have a distilled version, which makes more sense and is in fact more easy and juicier for you to translate into the next version, right? Now you can look at that particular sentence you wrote and say, that dark cloud was, ominous during that battle, which, took the courage away of the frontline soldiers, or something like that, and something like that, and say, and you try and find attestations for that, and you find, oh, here's some references that say that was actually what happened, right? And so you make that may be your entire essay, who knows, right? So like that, in C++ also, getting it down in proper syntax at the very beginning is very hard. And it's a skill that you'll only master after, I don't know, years of programming, maybe. So I think maybe months of programming, right? I think what might be good is get a notebook, right? Get a notebook first, and in your notebook, all you have to do is when you have to write something, just write it down. You don't have to write it down in the form of, even C++, just write it down in the form of pictures, right? Say what you have to do, right? And then say that is version 0, right? And version 1 is take those pictures and turn them into some words. There is some initial C++ on a piece of paper, right? For, we just say for, and then the variable, and then do the body, right? No syntax there. And then try and take that and turn that into a syntactical version of that. So all along you have a plan of what you have to do, right? If you don't have a plan, you're basically fucked at that point, because you always have the plan. So have the plan in a nebulous way, not nebulous, right? So you have it in an abstract way in your mind, and then let it dictate the concepts that you need. right? And then turn those concepts into ungrammatical, syntactically incorrect C++. That's fine, right? Do it, and then take that from there to and going from here to there will happen, right? So I think having the idea in your head and turning it directly into C++, it'll happen at some point, right? You don't have to get to the level of Shakespeare and before you start writing a concept that you have in your head directly into that beautiful iambic pentameter that he's famous for, right? But there are lots of writers in English, right? Not at the stage of Shakespeare, but still can produce quality work just like Shakespeare, but they didn't have to go directly from thought to the final metrical structure, right? So they had to do that windy thing, or maybe they had to pump it through an AI system or whatever it is, right? So they did that, but the end product is still the same. So I think like that, but you do that enough times, then you know that all the intermediate steps are basically just automatic steps, right? So I go from here to here, here to here, here. Those are all just automatic. So I can always relegate that to my subconscious. That can go to another part of my subconscious. So all of them become automata, right? All of them are mechanical. So I can go from the idea to the finished product directly, but it seems conscious that I went from here to here, but actually I went from here to here, except that all of that was basically subconscious automatic actions. I don't know if that makes any sense, but I think that kind of thinking about it has, helped me. And you can try into that too. All right, so what time is it? Yeah, well, we got almost an hour. So yeah, someone can pick up the code and yeah, it can be one of you again. Just pick up the code. We can try and code it, or you just call it the end. If you have any concepts that you want me to cover, again, happy to talk about it. If you have any questions, happy to answer questions. Anything you want to talk about, right? Ask me anything. We can have a conversation for the rest of this class today. We don't have any more classes.
I have a small question.
Yeah.
So if you want to so like now this is related to Quest 9, but it's mainly about string lists, or like let's say so you want to delete a member from a list. How I'm still unsure about how freeing up memory works. Is there a specific like does the delete thing free up the memory forever, or does I don't understand the what basically what I should be using.
Yeah, sure. Okay, so so delete is a counterpart of new, right? Every single byte that you do a new for, your program should have somewhere a delete for it.
Okay.
Yeah,
that's a very good rule. Thank you.
Yeah, and new basically says I want memory, but I don't want that memory to be on my program stack. I want it to be on the heap, and the heap of your program is basically your entire memory space, right? If you have 4 terabytes of memory, you got 4 terabytes of heap for you, right? It's the only danger with using the only drawback of using the heap instead of a vector is that it could be fragmented, right? It's all the pieces, the boxes you get maybe in different areas. So even though a linked list and that's the array, the advantage and the disadvantage of using an array versus a linked list. An array means that you have fantastically, implicit linear access. You don't have explicit linear access, right? Because you can just increment a counter and go to the next cell. You can offset by and go directly. So all of that is possible and it's really, really powerful. But but the disadvantage of an array is that you cannot have like a terabyte array. So technically you can, but it's not feasible. It's not feasible to have like totally big ass arrays in mind because in memory, because the arrays need to have contiguous memory space, right? So if you take that huge memory block and just reserve it in your array, that basically just locks up memory, right? It can't be used by other people. And so when you have huge amount of linear data to store, the best strategy to use there is a linked list, right? That's what I say. You can be a Python programmer, and many Python programmers don't know when to use an array and when to use a list, right? And what are the advantages of using they're both linear structures, right? And you could do these, but a list basically can span 4 terabytes, right? You have a linear structure that spans 4 terabytes of memory, but 4 terabytes of memory spanning and an array is, though it's faster, it's hugely inefficient and wastage, and it's a real big mess, right? So you can do these trade-offs. And so there's a point in which varies from application to application, situation to situation, where you decide this in this application, what I need is a linked list. And here I need an array, right? So, and the trade-off you make is between whether you need contiguous space or you don't need contiguous space. So those things you need to know. And those are the things that actually end up making your programs better, right, than the run-of-the-mill program out there. So yeah, it does take a lot of time to get used to that notation. Also the pointer notation, that Nick brought up before, and also being able to translate these code. So take your time, okay? Take your time. It is like, and people like Ben and Joe. I just keep this in mind, okay? This is just new syntax. This is new syntax. This is new tools, right? So you have an existing art in your mind, and you're just being introduced to new tools, right? You have a new kind of paintbrush. You have a new kind of canvas, right? So that's it. So you just have to learn how to use these tools. And all our exercises, all our quests, all our, everything we do in class, they're just environments for you to play around and learn to use these tools, right? So if you come here with that understanding, then you'll find that this is actually a great benefit to whatever you want to try and do, right? So maybe you'll come back in 2B and try and learn more skills, right? More tools, right? In 2B and 2C, we actually introduce more tools, right? More finer grained tools, and more important data structures. Each data structure is basically a fine grained tool, right? Basically, that's why I say computer scientists are really the best kind of scientists, because because to be a good debugger, you need to be a good scientist, because you need to be able to take a program that doesn't do what you want and construct an experiment. And an experiment is one in which you take your program and control for all of the variables that could cause your program to crash, except that one variable, right? So you control and say, that's gone. You're going to keep this constant, that constant. Okay, that's constant. Okay, so that's the only variable that's exposed. Now you can change that and see the effect on the output. So you can identify if that variable is buggy or not. Yes, and in order to control for these two variables, how do you do that, right? It's so, and you do that because, and it's really being a scientist, right? You're being a good scientist because now you're learning these fine tools to be able to chisel away at these points and knock them down so that these are, constant, right? Those are constant, they're controls. So being able to identify, and that's why I say, in these modern manufacturing processes, you spend a great deal of time just devising whatever it is, like DeepMind or right? That has to build that other thing, right? Which will give you the answer. Like, yeah, that's how we got down that entire track. I forgot that now, it's come back, right? So like that in computer science, you'll find that many times you have a problem, right? And you've built a solution and it works, but 90% of your effort is not in actually solving the problem, but is in actually coming up with an incredibly clever clever test bank, right? A bank of tests which can take your product and basically whittle away at all the fine nooks and crannies, right? And say, well, I have a very, very precise test case which was constructed, like by lake bending or during a total solar eclipse, right? Right. So I have a test case that I've constructed. I need to run that and see if this program passes that test case or not. Now imagine, right? Imagine the amount of incredible. So Nobel Prizes have been given to people who come up with these test cases in physics, right? So they come up with a test case and say, well, I'm going to run this test. And if this algorithm fails this test, this algorithm is wrong. Okay, we'll know it. And how do you come up with this test? So coming up with that test is sometimes a stroke of ingenuity, right? So many people just sometimes appreciate the algorithm, but they don't appreciate the amount of testing and the thought that has gone into constructing the algorithm, right? Maybe chipping away, like Michelangelo, right? You give him a block of stone, he chips away, and then there's a statue in the middle, right? And but chipping away takes a lot of effort, right? People just see the statue, but they don't see the effort that went into chipping away, right? So and debugging is that skill, and you get to be really, really good at debugging by being very scientific, right? So this is a science. There's a science bent of mind, and not only can art benefit science, and I think taking that scientific mindset and taking it to art also, right? So it has to work both ways. And I think also, the best arts that I have seen have come from people that have experimented with the art in a very scientific way. Right? So they try minor combinations of ideas, and they try and jiggle something here, and they can put themselves in the shoes of multiple observers, right? And say, well, does it work from this perspective? Does it work from that perspective? Right? So it's really hard. It's really hard because you can please one person, but you can't please like many people. So what is the trick in trying to design something that maximizes your pleasure surface, right? So how can you design something that pleases as many people? That's all, and I don't know, it's all subjective at the end. But I think I've seen, or I don't know, I've seen many pieces of art which have been guided by very, very, what I think are highly scientific principles, right? So scientific principles giving shape to subjective subjective sense of beauty, right? So you have a subjective sense of beauty, but in order to manifest it, you need to be able to bring some scientific principles to bear, right? So yeah, just like, you have a statue in mind, but using science, I can now be able to chip away at all these pieces that are not the truth, right? And then only leave what is really true, that is untouched by science, because science doesn't care, right? Science wants the truth, right? Science will chip away at everything that's not the truth. And what's left is that perfection, right? This is that perfection is what we're going for all the time. In any field, right? And so in Indian science, that is called the Brahma, right? Of any field, right? So in music, for example, we call it Nada Brahma, meaning that you can be a music student for many years, right? And the guru will not let you go, right? They won't give you permission to perform a concert on your own until one time, right? And that time is when the guru has realized that you have got Nada Brahma, right? So Nada Brahma means that you have now got the ability to latch on to a note, right? No matter what, latch on to a note, and immediately, given a particular contour, you'd be able to instantly recall all the pleasing contour variations around a particular note, right? And then immediately say, all right, so here's a particular contour, here's a note. Try and sing all of the possible ways in which that note can dance in that area. Because you take a note and you can dance in all kinds of ways, and all dances are not pleasant to look at, right? So it's a lot of work, millions, and not millions, minds, right? Lots of people have thought about these things, and some have died away, and the ones that have survived, right? So like in science and everything. So what are the aesthetically pleasing forms that of dance that are around that particular note at that particular point in time and space, right? Sing about it, right? So and then if you've got that sense at that point, which sometimes takes many years, you say, well, you've got the sense, now you can go away. So that's the point that people are looking at, even any art form, right? So I think in computer science and math, everything, it's the same. So and it's not easy, and it's not even a guarantee, and I don't know how that happens, right? Some people claim to know that they know how to make that sense awaken, right? To say, well, you give me a random student, I'll train them for 15 years and then make a computer scientist out of them. Like, Pygmalion and what is it? Henry Higgins, right? Professor Henry Higgins in Pygmalion, right? So he says, give me any person and I can make them a proper high cultured English speaker, right? Because in England at that time is cast in none of his classes and all. And Henry Higgins is an English professor, right? And in fact, it's very interesting because he's standing at the bus stop in England, and a woman comes by, right? And then she says something to someone, right? And he tells her without anything at all, right? Or maybe there's a question, right? She asks him a question, and in response, he says, "Your bus just left 15 minutes ago." Or 5 minutes ago, right? And she hasn't told him where he's from or where she's going, right? But from her accent, because he's an English professor who is so finely aware of dialectical differences between geographical areas in England, right? So he's able to place her within 2 miles of where she lives, right? And the time of day and everything, and her baggage. She knows she's going home, right? And she's and her bus, right? Is gone, right? And he's able to make that information. So he has an open challenge, saying, "Give me anyone you want. I'll turn them into a high-class English speaker," right? And then there's this woman. I forget her name, right? I don't know. The play is called My Fair Lady, right? It was turned into a movie, right? It's called My Fair Lady. Pygmalion. Right? This is the play by Bernard Shaw. And so anyway, he says, "Give me anyone and I'll turn them into a proper high cultured English speaker." It's a very entertaining film. I don't know, I must have watched it many decades ago. Anyway, where was I going with that? Yeah, like that in C++. I don't know. You can't take even me, right? It took me a long time. Even as a programmer, I've been a programmer, career programmer for a long time, and I did my higher education in computer science. But it takes a while. It takes a while for that sense, and that's what I think also musicians say, right? Or actors, and who have a like Anakin, and he says Obi-Wan is his master, and he says, "I'm good at everything. In fact, I'm even better than Anakin, but he's not letting me go." Right? He's holding me back. He's holding me back, and he wants to be. But Anakin is not looking for. I think this is my hypothesis, right? Because I know George Lucas was heavily influenced by all that mysticism and stuff. So this is my hypothesis. I think that Anakin was saying that, okay, well, he's powerful and strong, and the force is with him. He has a good sense in him. But the good sense by itself, you can come to it in two ways. You have to first feel compassion to all the other people, and then have good sense, right? Or know the truth, right? Because the truth is really powerful. The force is really, really powerful. If you don't have goodness with you and only have the force, you can basically go and basically destroy everything, right? So I got to hold on to this enormous force until such time as the cover of compassion is able to cover it up, right? Otherwise, this force is basically going to destroy everything. So I just need to hang on to that. And Anakin, of course, is young and bold and restless, and he wants to let go. Anakin to let go, and he says, "No, God, you're holding on to me, right? He's holding me back, not he's holding me back." And that's why this whole story was born, right? Because bad tried to break out prematurely, and before it was fully cured. Right, the olives are really tasty, but they got to be cured first. Like the tannins in I tried tasting the acorns. Acorns are really bitter, right? So they have these tannins in them, and tannins also are in tea. And that's why the tea is bitter. But for some reason, the acorns, I can't smell them. I don't know if anyone can smell acorns. I can smell them, but the squirrels seem to be able to smell acorns from a long distance away, because last time when he was here, I gave him an acorn. He didn't take it away to bury it elsewhere. He just peeled it and ate it right there and left the shell here, right? So, and I said, what a big mess. I'm going to clean it up for him. And I took the shells and threw it in the trash can. And then the next day, I had a lot of goodies out there, right, near the trash can, but not acorns. And he didn't want any of the goodies, right? He would just keep going in the trash can to look for the shell, which is not even the whole acorn, right? It's just a shell. So there must be some really strong odor, right, that humans can't tell, but this attracts the squirrels like crazy. So maybe I just, when you soak the acorn in water, the water gets all black. Maybe that water, I can sweeten that water, and that water is acorn cola for for the squirrel. In summer, when he comes by, I can give him acorn cola, the black water from soaking an acorn, and we'll see how he takes to that.
I know, I obviously watch Star Wars, and I know I understand that that reference you've made, and if you think about it, the overall plot about for the prequels was really good. It just, the reason why a lot of people didn't like the prequels was because of everything around it. But
I like them.
Really? Yeah.
Yeah.
I liked it too. Especially episode 3. But I don't know. I really like the plot of it's kind of Shakespearean in a way, which was which was a man who is eager to move ranks, and eventually follows his own hubris is something.
It's the same story, right? It's the same story and different, coded with different ways. And there was in fact a long time ago in a magazine called Mad. There was they took Snow White and the Seven Dwarfs. No, Cinderella. They took Cinderella and dressed it up in 5 or 6 different ways, and each of those 5 different ways were actually blockbuster films at the time the magazine got released. So it's exactly the same story, like you said, but changes to the surface. Like C++ and Java and Python, but they all get translated to machine code.
Oh, by the way, I remember. Well, obviously, this was earlier on in class when you brought up Oh, sorry, something. When you brought up a machine that writes itself, I actually did something, well, obviously, much simpler, and it was just using just basic JavaScript properties. So
Yeah, question
I
nine.
had to dynamically load JavaScript into a web view, and in order to do that, I used something called execute script. Basically, what I did was I would write JavaScript, but then put that in a string, and then I would load that into that function, and then it would execute that inside of WebView. But what happened was I had to dynamically write the JavaScript code. So basically, it was kind of like dynamically writing a string that would then get turned into JavaScript, but it was kind of like it was writing itself. And I don't know why, I just kind of, I don't know, I just thought of it when you said that.
I see. Yeah. Maybe you were thinking about it about in the context of bootstrapping.
Yes.
Bootstrapping it.
Yes.
Yeah, JavaScript. I don't know. I think different people do it different ways, but I prefer to keep as much of the computation on the server as possible. It's easier to do things in Python many times. I tend to keep my JavaScript as restricted as possible to the UI elements, right? Where the user has to.
That's a very good practice, because it's better for security. I mean, people can open developer tools and see all of your JavaScript code, but they can't really see.
Not only that, but I think data processing in JavaScript is actually quite a bit of a pain. It's in Node. I know there are people who just do it in Node all the time. For me, I've been Python. Everybody's done in Python. Someone has done it already, so you just need to locate it.
Yeah, exactly. I know what you're talking about. And yeah, doing as much as you can on a server is it's definitely a much better idea than doing that all on the client side. Also, it gives you the benefit of not having to use
it gives you the benefit
not having
of
to use JavaScript. Basically, you can make it any language, Golang, C++, whatever you want on a server. And
exactly. Once it's on the server, you can just run it in any language you want. In fact, you don't even need a server. You just do a Lambda on Python on one of these cloud services. And I think most of the Lambdas can now even be written in. I'm pretty sure Lambdas can be written in Python, Java, PHP, and even Node. Node. You can write JavaScript Lambdas too. So you don't even need a server. In fact, whatever you're writing in JavaScript can just be a Lambda, which means that it'll only be charged. You don't get charged for a server running 100% of the time. You only get charged for the time that your Lambda is actually in execution, right? So it's like a server. So when someone hits a server and then the code runs, right? Your PHP or Python code runs and return the result, right? So what is a fraction of time your code is actually running during that request, right? Maybe it's running for 5 milliseconds, right? 5 milliseconds on each call. 5 milliseconds, right? So 5 milliseconds is a lot of time. So, for 5 milliseconds, but you're actually paying for 24 hours of the server each day. How cool would it be if you didn't pay for 24 hours, but you actually paid for 24, that many seconds by the second, right? You paid by the second, or even by the millisecond, or by the CPU cycle. So you chop it up as finely as possible. That's really cool, right? So many of these cloud services these days allow you to just do it as a Lambda, which means that instead of paying for 24 hours, you could basically pay for the same 24 hours split over 500 years, right? Same 24 hours, well, not 500 years, obviously. And again, the power of the Lambda is that if your service, what you've done is really, really powerful and popular, then it'll get a lot of hits, right? So you only pay for the hits. So if nobody's hitting your service, you don't pay anything at all, right? And only if a lot of people are hitting your service, then only then you start paying even mediocre amounts, right? There's small amounts, because a lot of people have to hit to keep the 5 milliseconds accumulate into something sizable that you pay for, right? Like $10 or something like that. And that takes a lot of Lambda hits. So yeah, these days, language is not a barrier at all. You can write it in any language you want. I
know what you're talking about though with that, and I'm actually I know that the way it works is, actually I'm not entirely sure. Do they just shut off the servers when you're not using it? How does that work when somebody eventually decides to send a request to your website? Does it turn itself on? Does it stay idle, and then does it use something? Oh, I have an idea. Maybe it does stay idle. It uses and then it uses that processing power for what it actually for another person, and then when so the server is still on, but it's using the processing power for someone else, and then when you need it, it will run, I guess. Yeah.
Absolutely, that is right. That's exactly the same. And now, in this context, look at how Tesla, for example, right, is going to do with what is it called, the Tesla fleet, right? Where you can buy a car, but you don't have to buy the whole car anymore. Right, you can buy. It's because Tesla is trying to do exactly the same thing in the automobile industry. You see, it's Amazon and Google and Microsoft. They did it in cloud, right? So they said you don't have to buy the whole computer, just buy individual cycles, right? Or buy a whole computer. When you use the computer, will you give you the cycles? But other times, why are you paying for the system being idle? We'll use the same computer for someone else's cycles and get them to pay for it, right?
Yeah, that actually sounds like a really good idea. I haven't heard about that until now.
No, Tesla. No, you just look up
for
the
Tesla,
right? So they've been trying to do that in the automobile with fleets, saying you don't have to pay for the whole car, right? So the car costs $35,000, but don't pay for the whole car. You're not going to use it 24 hours at a time. Use it, but whenever someone else wants to use a Tesla, a ride somewhere, we'll send your car out like Lyft and Uber, right? So it'll make money 24 hours a day, right? And so you only pay. Amortizing things, right? You only pay for a sliver of the 24 hours that you actually own the Tesla for. The rest of the time, the Tesla is out there serving other people. So if you abstract it out, it's exactly the same thing.
It's
right?
like Uber on steroids.
Yeah, it's exactly right. So that's why we can think about this model as succeeding with a higher posterior likelihood. Having seen the success of that model, so people who are able to abstract it out can see that's exactly the same, right? It's the same model. That model has already proven itself in the computational cloud field, right? Where people are preferring to use lambdas instead of dedicated servers. So that model is fantastic because it lets people not waste resources and only pay for what they want, right? So that is fantastic, which means if that has proven itself in this area, it is very likely that if the probability of that being successful in automobile is X%, now it is maybe 2X%, or not maybe 2X, right? 1.5X%. This is increase the probability that the same model applied to automotives will actually be successful. So if you had previously thought that, should I, whatever it is, right? Should I support right? So you can let these factors decide, and it's the same model, right? So obviously they've brought it to so you can think of the same model applied in other areas, right? So maybe you can think of this, oh, is it possible to apply the same model to, let's say, surgery? Obviously you don't want to be doing that to surgery, saying, oh, hey, surgeons do it remotely, you're going to be operating on this guy's heart. When you're done operating on this guy's heart, oh, you're going to be free now, okay, operate on that guy's heart. All of that you can do from your home remotely by operating these virtual fingers will take care of the thing. That one is that operation, that surgery is happening in Cairo. Oh, that one is going to happen in Chennai. Oh, that one is in Shanghai. All right, but you're sitting at home, right, in your pajamas, right, with your virtual gloves, right, and you're doing these surgeries, bam, 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 like that. And so surgery could be commoditized like that, right, where in fact, you could have a automatic system just directing surgeries from a central place to multiple locations in the world, right? One after another, right? So surgeries don't have to be so expensive because you don't lock up a surgeon for the entire time. The surgeon could be in their office, right, and reviewing critical things that get sent to them it could be a bank of surgeons, right? They could be anonymously reviewing things that are being sent to them by this data bank that is concurrently managing 1 million surgeries all around the world. It is able to identify, right, this surgery is performing well according to plan, according to the plan that's been built into the system. It's going to be 90% chance of success, right? 80% chance of success, 95%. Oh, that's going to be 65% chance of success. Let's take that and send it to the surgeon bank, right? Where you have human ingenuity to bear, right? So which is next level intelligence, which hasn't yet made it into the AI, right? So they can review. these cases and say, okay, well, in this case, do that, not this, right? And so all of that, everything. So this is, I think this is where we're going, right? We're going to a place where we don't have to pay for anything that is beyond what we need. Right. So I think, and I think that can only result in greater happiness for humanity, because a lot of people, a lot of suffering, I think I see around, it's really caused by people, buying and wanting things they don't really need, and for the sake of some future situation that is not even going to happen.
Is that like, can I explain?
Yeah, sure, go for it.
I mean, can I ask?
Yeah, absolutely.
So you're saying, I think I might have heard this, like, we might buy less stuff, right?
Yeah.
And rent more, for example, right?
I missed the last bit.
And sort of like borrow stuff or subscribe or something.
No, I don't mean it in that way. I mean, I just mean, yeah, you can borrow and subscribe, I guess. I don't know. I just mean that, there's a lot of stuff that's just out there frozen, not growing and not helping other people also, right? And I think if we just get, I don't know, it's to each person their own, but I think that, that there are some of these are conducive to our happiness and some aren't. What I find is not conducive to happiness is stuff that we basically lock away for later. Because when we lock something away for later, we've also locked some of ourselves away for later. Because now, until such time as whatever we lock away for later has been realized, that basically just becomes, like Voldemort's soul, right? It's not like Voldemort. It's just become out there. It's out there. We can't let go of it. We can. It's karma. It's stuck to us now, right? We can't let go of it. And we have 1,000 things like that. 1,000 things are just going to hold on to us, right? Because the reason we can't let go of it is because we actually did invest effort or whatever it is we think we deserve it, right? We put some effort into buying it and saving it, right, for later, and we put it out there, and we can't just let it go and be free, because what if it disappeared? What if someone took it? What if it decayed? What if it broke? What if it was an earthquake, right? So we always have to be worried and say, well, I got to take care of it, right? I can't let go, right? So and then you may think that one of those doesn't matter, but I think what tends to happen insidiously, at least in my life, is that lots of these things, right? Lots of little things which individually you don't tend to notice, but together will insidiously collect and weigh down on you by freezing you, right? This is like being held back by lots and lots of chains, like Anakin, right? This is being held back by lots and lots of chains that you can't move in any direction. Any direction you move, there's going to be pain, right? So it's constricting because there's no freedom at all. You got to be sure that whatever you do, you don't break something, right? So, and that's not a very productive environment to be in, and I don't think people that want you to be in that position where you're unproductive will help you, right, to reach your maximum. So what you need to be is really free, and in order to be free, you can't really attach yourself, right, or let yourself be attached to all these things. Just that's why someone asked me recently, because it was related to me in my past life. So I said, I think the best way to be happy is just get what you need and make sure you have a basic basic security out there. Like make sure that you're not going to be in crazy ass badass situations and do some stupid thing, right? Or end up in a situation where you are going to be very unhappy. Don't just take. And I bet that in modern societies, you don't have a great deal, right? So not just modern societies, even ancient societies at the times of their heights of civilizations, right? At that, every society goes through these peaks of civilizations, right? I think there, people basically realize that contentment and happiness is more important than everything else. And so basically say, well, you don't have to do anything, and this is what you'll get to be content. And I think the suffering really starts when people say, well, I want to be more than content, right? So, and I think more than content is not really real content, right? This is really fake, and it'll all go away. And then the real happiness is never found, and people will just be slaving away and tied to so many things, and they're not free. They will be bound until the day they die, and that's not a good way to enjoy life, I think. So that's why I think I don't even know how we got started talking about this crazy thing. Anyway. That's that's what it is. Well, considering it's the last class and we don't have anything else useful to talk about. What else? Is there anything about C++ that you think will be useful? C++ or programming?
So
Or
can
any
I
other-
first can I first tell you what I think it is? And
Yeah, sure. Go for it. Go for it.
oh, I'm also having a trouble with quest number 9 where I get like some kind of like
Yeah, I
Have
saw.
something
Hey,
nine.
hey, Chad. So
I asked this on Reddit because you were
CLYA 900. Is that you?
yeah.
Okay.
Sorry.
Right. So you realize that,
I accidentally logged into that account on the last. Don't worry, my other one says Chad Y, and
oh yeah, all right. Don't worry. Okay,
I
just wanted
accidentally
just
logged
wanted to
into
know.
my old account.
I just wanted to know. That's fine. Yeah, everybody gets help, obviously. But I wanted to know because this is not, it won't get you participation point from the Reddit, but you probably will max out anyway through class participation. So I wouldn't worry about that.
Oh, cool. I think I'm going to get max from the class per.
Yeah. I think most of you guys are very active then. Anyway, what was I saying before? Well, quest 9, you got to figure it out. Okay, so yeah, I think you'll find the answer.
So I got to figure out, what, maybe I should probably test a few methods and.
Yeah, write your own test cases. Hey, you know what? This guy, so there's a student, John in my 2C class, right? He just made a post this morning. I think he completed all of the quests all the way in red. And he made a summary post saying he started at Fangs and this is what, and some of the advice he gives to future questers is actually very useful even.
Oh, can I nominate him? What's his username?
Yeah, no, don't do that. Don't do things that I say, or just do what you feel, right? Forget that I mentioned John today.
Cool.
Yeah, just do what.
But still,
because you may find that lots of people that have posted in your classmates might have posted really useful shit, right? Or you could just look at immediate, past. Yeah, right. And then later on in your recommendation, I would always mention that too, right? So he was the MHM member winner, right, for this quarter, most helpful member. And I think that carries a great deal of value for professors, right? So grad study is different. Oh yeah, this is where we're going, right? So high school, grade focused, right? And I think what happens is many students who come to community college, they have to prepare for university education, which is research based mostly, but they come here with the same mindset as high school, which I think is unfortunately different in the Bay Area. They can't come with the mindset of getting grades again. Because and getting grades and a piece of paper that's going to get you there, you will have a very unhappy life. You either drop out of university or an unhappy life, right? Unhappy life. And so you should take advantage of this and say, this is your place to transition your learning method. If you've been learning the bad way before, learning for the piece of paper grades before, this is your chance in a community college to turn it around, right? Turn it around for low cost. Turn it around for low cost and say, I'm not going to learn for the credit anymore, but I want to learn for the sake of learning, right? This is your great chance, because in a community college, you find a lot of people who want to teach you for the sake of, teaching, right? And you learn for the sake of learning. So what better marriage can take place, right? So here is where you can turn it around and say, I don't care about the grade. What I want is now to pick up a lot of skills, because and also, and part of the skill is not just learning all the tools, it's also learning to help other people, right? Because and be naturally curious. How would you even show that to a graduate school advisor? Because that's what they're looking for. They're not looking for A+ anymore, right? If you're coming from a community college, or they're looking for people who are not just A+, but who are able to be good researchers. If you're able to be a good researcher, then you'd be helpful to that faculty member, right? To make publications, and you help them with experiments. Because even if I want to run some experiment and it's going to take lots of data to gather carefully, I'm not going to put any damn student on it. So I'll take a student who's well versed in the scientific method, who knows how to control for things, right? And you can't run an experiment for 5 days, and at the end of 5 days, and you look at the data and say, well, it's really wacky. Did you actually control for that variable? And you find out, no, they didn't control for that variable, right? And you would have trusted them, right? And say, well, they're going to run this experiment properly, and they're going to give me, data that only responds to this one guy. Right now, ultimately, you find that the data responds to 2 guys, not 1 guy, and they didn't control for the second guy, right? And you find that out after 5 days or 1 week, or some experiments run for several weeks like that, and it's all a waste. Well, not a waste. Maybe you got to run another thing and run multi-factor analysis and all kinds of crazy shit like that, right? So that's why when you say you want to pick a student to run an experiment, it's graduate advisors. That's what they're looking for, right? They're looking for students who are so interested in the subject, right? Not in the piece of paper. You can get the piece of paper, but not be a good experimenter. You can't have the good, the scientific sense. You get there and say, I can get the piece of paper, but that's not the main focus. My study here is to learn how to work with others, and also explain all these concepts to other people, because as a grad student, I'm going to be learning new things, but I want to be able to explain it to all, I want to be a TA and explain it to the other junior students, because in the process of explaining it, I might be able to, come up with new angles with which I can refine my experiments. So all those things, those are what grad advisors are looking for. When you ask me for recommendations, if I say that not only did this person contribute according to this login ID that you can check for yourself and make your decision, but they were also the most helpful member of that quarter, as you can be seen by this election process or something like that, right? And when someone sees that, I bet it'll sway the pendulum quite a ways to the other side, to the side of favoring admission, and saying, oh, this is someone we want to have in our college, right? Rather than someone who's just going to use our college. Because a lot of people use the college to get a piece of paper with the college's name on it, right? So if I was some famous college XYZ, and someone wants to get to XYZ just to say I got a certificate from XYZ, right? Then I know that person is worth $200,000 of money for me, right? Because that's all I can ever get from that person, because they're coming here using me to get a piece of paper. So that because they're using me and not going to really enrich me in any way, I got to charge them full price, right? So that's $200,000 for 4 years, right? So give it to me, right? And I'll give you the piece of paper. That's fine, right? Whereas this other person who comes here saying, well, you know what? I'm not so interested in just getting a piece of paper from you, but I want to be able to contribute to the field. I want to help you publish a paper. I want to help you complete that experiment, which we can use to uncover some great mystery about the universe, right? And marvel at it together, right? Those kinds of things. Even if you didn't get A+, I don't care, right? Because then I would say, well, you know what? I'm going to get a lot out of that person, so I'm not going to give them, I'm not going to charge them full price, right? Full price is $400,000, $200,000 for 4 years, right? I'm not going to do that because I'm going to get a lot of, I'm going to give them fellowships, tutorship, TAs, RAs, all these things, right? So I give them so that I make it very easy for them to come and work with me as a grad student. In fact, they'll feel like they're an intern getting money by being a TA, right? So they get more money to pay for their courses and also their livelihood and other expenses by being a student. Then so that's what happens, right? You go to all these big name schools, they charge a lot of money, but they charge a lot of money for all these people who want pieces of paper, right? So that's a really great way, right? You take money from all these people who don't really value knowledge, right? They don't deserve money. So you take money from these people and give it to the money, give the same money to the people who actually value knowledge, which is, give TAs, fellowships, grants, scholarships to the people who actually know or want to learn, right? So take the money from, what's the money? There is actually a saying about this, I think, money, maybe I'm pretty sure Shakespeare says everything about money. Yeah, everything about everything, but I'm pretty sure there's something about no, but there is something about money. Money, a fool and his money are soon parted, or something like that. Right? Because people who pay full price for these high quality stuff, or purportedly high quality stuff, right? Named by or assumed by other people to be high quality. They're only paying for the piece of paper. They're not paying for quality. Even though other people might say high quality, if you buy a small tiny Louis Vuitton bag, right, and you go shopping, and then anything you buy actually needs to go somewhere else because it can't go in that small bag, except it has V gold embossed label on it. Then you're just misled, right? You're misguided in a sense that you're doing a lot of work just lugging around, getting free advertising while not extracting any utility from it, which is really the reason why people buy bags. Yes.
I want to say two things. First of all, it's a question. I just want to know. Did you get my email?
I did. Yeah. Unfortunately, computer problems at the last minute. But anyone who is in quest number 9, I'll make a post about it today. Okay. So anyone who has already reached quest number 9, has a freeze date of Sunday after the finals, right?
So the 28th, not the
28th,
21st.
28th, yeah.
Okay, thank God.
Forget about it. Just
Oh my
focus,
God.
focus on the finals. Yeah,
I
focus on
was
the
so
finals.
stressed. I slept, or I was awake 26 hours yesterday, and
Geez.
then all of a sudden, so I was like,
Yeah.
I was on mini quest, the mini quest 10. All of a sudden, I was eating a sandwich and I had some lemonade. I picked up my lemonade. It hit my computer
What time
monitor and
was it?
it's,
If I was awake, I could have replied immediately, but sorry, it took me a
oh,
minute.
don't worry about it. I saw the reply. I replied to that, asking, confirming that if it was the 28th.
Yeah. Anyone
yeah.
who's on Quest 9, yeah, until the 28th. What I'll do is that on Sunday, this Sunday, I will migrate all of the scores for the later quest into Canvas. And then for those who are at as of Sunday, not even today, right? As of Sunday, when I migrate the scores, those who have non-zero scores, you have to have at least 1 point, right? In quest number 9. Those who have non-zero scores in quest 9, I'll re-import the scores for all of the quests again on the 28th. All of the quests, right? Which means that you can basically forget. If you've got at least 1 point in quest 9, forget about questing until after the final. So after the final on Thursday, you take the Thursday morning, right? So first thing on Thursday morning, do the final, and then you have all of Thursday, Friday, Saturday, all of Sunday, right, to complete your quest. I think it's a piece of cake.
I haven't submitted anything for quest 9 yet, because what I do is I work on my mini quest, all of the mini quests first, and then I submit it.
That's fine. Just do one, right? Just do the first one, which is just a constructors, right?
Okay.
Okay. And then you just get your student ID in the place, in foot in the door.
And the second thing, I just wanted to make a comment, because I've been thinking about this recently. There are a lot of fancy terms for programming, but fundamentally, what I've realized is programming is kind of, it's like a toolkit, and what you use the toolkit for, or and the way that you use the tools in the toolkit, in order to achieve anything in programming, really, you have to figure out creative ways to use the tools in the toolkit. And classes like CS2A, they just give you more tools, and they help with that kind of problem solving that helps you come up with creative ways to solve that. And I don't know, I just thought of that, and I was like, that makes a lot of sense.
No, I absolutely agree. It's correct. Yeah. And 2B and 2C give you even more tools. You finer grain tools, so you can go between the cracks and then get these fine cuts. You can in 2B and 2C you'll learn more. I think 2C is more about 2B. You'll get more tools. In 2C you'll learn more techniques of how to use the existing tools, right? So, for example, you may have a particular kind of chisel, but 2C will show you how you can take that chisel and use it at this angle so that you can get a fine, unusual cut, and which is really, really useful, right? So all those things you learn in 2C.
Well, I'm excited to get into 2B.
Yeah, totally.
And then 2C.
I'm excited too. In fact, I won't see most of you next quarter because I'm not teaching 2B. But hopefully I will see you, some of you at least, in my 2B. And what is the next one? Well,
2C.
Yeah, don't do summer 2B, okay? Because it's not worth it. You need to enjoy each quest in 2B, not just rush through it. So yeah, I'll see you in fall after the final.
So
a tiny question on that. In your opinion, I guess. So for context, I'm looking for a transfer at some point. I don't even know what college, but right now I'm just kind of setting up for a UC. And so I took 2A just now, surprisingly. And but I was wondering if, like, just for personal development and for a bit of like putting on my resume, but more so for personal development, which one do you think would be more useful or practical? That's a weird question to ask, but I'm asking between C++ and Python, to continue going down 2B and 2C, or branching into 3A, 3B, 3C classes instead.
Sure, sure.
And
So
keeping in mind that I have taken an intro in C++ class
I
just now.
see, I see.
Um,
Now, so what do you want to major in, by the way? So,
I am a computer science major right now. I
Oh,
don't know if
computer
that's
science,
gonna
okay.
stay, but
so if you're a computer science major, here's what I would suggest, right? Just stay on C++. And the reason I say that is because, once you master C++, and Python is a piece of cake, you can do this, right? Ultimately, it's in any language you take, people say learn it in 21 days and learn it in 7 days and learn it, right? It's not learned and not for anyone, right? So
Yeah.
it is in fact possible. It is possible to learn Python in 21 days or even 7 days, right? But it's only that statement is not targeted at random Joe, right? It is targeted at C++ programmers, right? Or programmers who have been programming for a long time in another language.
Yeah.
Right, because learning the syntax of another language, which is, it's like saying, French and Italian, right? It's just minor differences too, right? So if you know C++, going to Python, it's nothing at all, or JavaScript, any other language. But if you're not a computer science major, I would say now would be a good time, right? CS2A, absolutely, everybody should do, because they need to know. If you're going to be using computers, you need to know what they're made of, right? So I think CS2A everybody should do, but non-computer science majors, this is a time when they should consider branching off, right? So like, for example, even, Ben and Joe, this is the time. They could basically say, well, I've got a good taste of computer science. Now what's possible using computer science? Now let me go back, right? So give computer science a break and go back and what I usually do, right? I'll get really good at that. And then when I'm trying to do what I do, I come across several things that most of my contemporaries will say, no, that's not possible, that's not possible. But I can bring to bear what I learned in computer science. Or maybe if I go back now, if I go back and pick up that other skill that I can do, and then I can show my colleagues, hey, using this, I can do that, right? And then you set a new precedent in your field, And so that's all possible. So yeah, certainly for non-CS majors, I would say just step away. At this point, you shouldn't say you should, right? My recommendation is that if you're not a CS major, if computer science is not your heart, right? It's not burning in you and saying that's where you need to be, you'll feel frustrated, right? You'll feel frustrated in 2B. You'll end up complaining and blaming everyone. Not necessarily, but you may feel very frustrated. And also, yeah,
I can see that. That was a good answer. Thank you.
Thanks. By the way, it is close to 10 o'clock, and it is the last class. But obviously, like I said before, if you guys chat on Discord, you have to, right? You have chat in your own personal channels and identify. It shouldn't be the same persons, right? Find people of your own, right, that you want to nominate for this prize, and you don't need to give me a receipt, right? So it's all tax paid already. But you do need to declare it as income in your own tax returns, right? So if you're making money, so because to the government you have to say, I got this $250, and there's a small amount that'll go as tax, may go as tax to the government, but you have to do that. You don't have to give me a receipt, but no, do nominate people, and even nominate yourself. That's fine, right? But you need to have that one post, one post that I can link to when people come and vote, right? So each section I'll pick seven candidates, right? 7 in 2A, 7 and 7 in 2C, 2B, right? And so there will be one winner in each, right? Not
and we only get one vote, right? Or is in
everybody gets
or
one
one
vote.
nomination?
Yeah, Reddit will take care of it. I think everybody gets one vote. You can obviously talk to your friends and everybody else and say, hey, vote for me, or vote for this person. So you can do all, offline lobbying is fine, right? I don't care, because anything I can police is fine. And keep it fun and interesting for everyone. And just because you didn't, your candidate didn't win in this round, in this quarter, does not mean that, especially if you thought it was their contribution was valuable enough to be nominated, it's pretty likely that someone else down the line next quarter may also nominate that person, right? And maybe in that time, this person has also made a few more posts, right? So that person can win. So if you haven't won, it just means you still have a chance to win. If you won, then that's it, right? You can't win blue anymore, right? So you just have to be MHM in green and MHM in red. So you can win a maximum of $750 over 3 quarters, right? But only $250 in each quarter.
Makes sense. And we can only nominate one person, right?
Only
If we-
nominate one person. Yeah.
All right. Makes sense.
And feel free to nominate yourself too, right? Yeah, I just need that one post, and I'm not going to say this was nominated by that, right? So when the votes go out on Reddit, I'm not going to say X nominated by Y, right? Because for all I know, it could be nominated by multiple people, right? You won't know. So I'll just say these are the candidates. I won't say X nominated themselves, right? Nobody will know. So you should feel free to do that, right? And there's no reason why you should not consider nominating yourself, right? In fact, you should basically step away and just basically find the most helpful person. And if that most helpful person happens to have the name the same as yours, that's what it is, right? So yeah, you shouldn't feel constrained to.
And we talking about the most helpful person in general or the most helpful person on the subreddit?
Yeah, in the subreddit. Sorry.
Okay, in the subreddit.
It could be context. It could be posts due to tips and tricks also, tips and tricks and other posts, but it should be on a subreddit.
Makes sense.
Great. All right. Well, unless you guys have any other questions to ask me, yeah, and obviously I said, you feel free to schedule a time later, and I'm happy to come back and talk. But otherwise, I think we can call it a day and call it a quarter. Right? So this is the end of the line for CS2A.
I have one small question.
Sure, yeah, go for it. Go for it.
So let's say, I'm just going to use the node or struct example from Quest 9. So in the constructor, you defined it as, node pointer head, node pointer tail, etc. What's the difference between doing it like that and using new?
No. New is what gives you the actual memory, right? Head and tail and all these things in your node. They just point to where the memory is. They're not the actual memory itself. They're just pointers to where that memory got out. Yeah. So new is what your constructor will do the new, and then once in your constructor, when you say give me new memory, it'll give you new memory and give you the address of it, and your head will now be that new memory.
I see. Thank you.
That answers your question, right?
Yes. Thank you.
All right.
Hi, Professor. I have a quick question.
Sure.
Going back to the class 2B and 2C. I'm debating maybe I would like to take your 2B and 2C, but I know it's not offered next quarter, so I'm thinking maybe for next quarter and maybe this summer I'll just work through the blue quests. And will you be teaching 2C in the fall?
Yeah, totally. Yeah, so fall and winter, I teach all 3, and then spring I only teach 2. But I'll talk to Beta and see if there's some way I could do all 3 every quarter. And then, yeah, but not this quarter. This time, unfortunately.
Let go now if that's fine.
Yeah, you can wait a quarter. And
Beta for Beta for 1C. That's right.
Beta teaches the Java track. She's our department chair.
Interesting. Okay.
So yeah, so take it slow. Unless you're in a hurry, right? Take it slow.
Right.
And you can also do someone else's 2B section, right? And then do the quests. Nothing stops you from doing the quests, right? And you should, in fact, if you have relatives overseas, in maybe overseas in other countries where education is more expensive, you could tell them to just log in and do the quests by themselves.
Right.
It's free, right?
Yeah.
All they need is
actually, that's what I intend to do. I just want to go through the quests 2B and maybe just sign up for your 2C.
Yeah. Write a small guide maybe of how someone should approach these quests, and maybe send it to one of your relatives or friends overseas who has an expensive education system, so they could basically just teach themselves, right? Instead of, I know there's tons and tons of classes online. Okay, you can go online and do these classes and courses at Udacity, but this may be a way in which they can actually progress, just like LeetCode, right? So LeetCode also has these challenging problems, right, of varying levels of difficulty. Yeah,
Yep.
but here, this way they'll know that there's also a set of problems that are being cherry-picked, selected, so that it walks the contour. It walks the contour from beginner to advanced, as required by the government of California after decades of research, right? So the CIDs and the particular courses that are required and the contents of these courses, we didn't just come up with this out of thin air, right? So one morning, not a bunch of our faculty came together and say, "Oh, we got it." No, these have been like science, right? They throw all of these together, and over decades of experience, whittle away. This concept is not necessary. That's not necessary. It's all there, but not all algorithms can be taught, right? I don't have the time or even the desire to suck away everything from you, right? So it's okay to taste a little bit of the dish with you, but then I shouldn't be, taking everything away. So the most juicy bits I'll show you, right? And then the rest of it is up for you to discover.
Excuse me.
Mhm.
Can I go right now?
Yeah, sure. Yeah. In
Thanks.
fact,
I have breakfast. So.
Yeah. And
But that was nice talking about the, how to fix the mini quest I saw.
Yeah,
I'm gonna
yeah,
figure that out.
here you go. Take it.
Oh, well, your squirrel.
Yeah.
Is your squirrel like pets or not really?
Hmm?
Does your squirrel like being touched or not really?
He doesn't care, I think. Yeah, initially he was scared, but then now he comes and just butts my, finger.
No, I mean
now.
like petted.
No, he actually just, knocks his nose on my. Yeah. Well, maybe he wants a cookie, but I'll get one out for him.
Cool. He doesn't like being petted.
I try not to anyway. I don't know.
Yeah, I mean, it's probably a bad idea to pet the squirrel because it can carry disease, right?
No, not like that. I don't want to make him dependent on me, right? So, I mean, if I'm here and I give him a cookie every time he comes here, then he may lose the ability to fend for himself.
Oh, makes sense,
Yeah,
they
then
should be
he gets
wild
vulnerable.
animals.
And if he gets too trusting of humans, and then he just goes to some random human who basically just kills him.
Yeah, that's actually bad for wild animal, unlike a domestic animal like a cat.
Yeah, exactly. So you just got to be sure, be careful not to overtrain. Yeah, like machine learning, right? You got to be careful not to overtrain the system.
Bye.
Yeah. Hey guys, so yeah, you're free to go, by the way, right? You're free to go. And it was great fun having you guys in my class. And thank you so much. Okay, thank you so much for driving so many times, helping me out, being patient with me, right? And humoring me when I just go off on tangents and talk about total nonsense. So it's not. I appreciate it. Let's put it that way, right? I appreciate it because it's not nobody's obliged to listen to your nonsense, right? And but you guys do. So thank you for that. All right. So I'll see you guys.
Class that genuinely helped.
Thank you, Professor.
Yeah, no worries at all. Anytime any of you guys want any help, just let me know. Except college recommendations, my policy, right? So but most of you have done fantastic contributions, right? You should be proud of them. And continue making contributions, and then eventually when it comes time, you can pick a few salient pointers, and that will basically speak for itself. All right, I will see you guys hopefully in the future. Yeah.
Yep.
Thank you.
Thank you.
Best of luck in your exams.
Yeah, thanks.
Thank you. Bye.
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 Thank you very much, Professor.